Hello class, and welcome to our Chapter 2 review. So to start, we have these. I want you to write each decimal as a fraction or a mixed number in simplest form. So I want you all to try this. Let's look at this. Who can read me this number? And I don't want you to say 0 point. I want you to read it properly. Who can read me that number? Alexandria.
0.3.
Yeah, so it is 3/10. There we go. I already made it into a fraction. Emma, can I simplify this?
No.
Nope. Look at that, you guys. That's the first answer. As simple as that. What about this next one? Jack, how do you say this?
6,500.
6/500, like a little good Southern boy. Exactly, 6/500. Can I simplify this? Yes, I can. They both end in a 5 or a 0. Nathan, what is their greatest common factor?
5.
Yeah, so we divide them both by 5. So we do what we do to the top, we do to the bottom. And then Nathan, what is our final answer?
13/20.
Perfect, 13/20. If you're having a hard time with this, make sure you know how to do your division. So now here we get 13/20. Exactly, and I like the way that you guys are saying these, because saying it 6/500 tells us exactly what we're going to put it over. What about this one? Harry, can you read to me this number, please?
9 and 3,500.
Perfect. So our number is 9 and 3,500. Do I need to care about that 9 and simplifying? Do I need to care about the 9? No, the 9's already what it is. It's just going to be a 9. I only have to simplify the fraction part. So let me see. I want to simplify the fraction part. Emma, what is their greatest common factor?
5.
5. Exactly. Jaden, when I divide, what do I get my new fraction to be?
7/20.
Yes, 7/20. So my new answers for all of them are 9 here and 7/20. So I've got all of that. These are my answers. Pretty straightforwards, right? So far, pretty straightforwards. What were we doing? What were we looking at to tell us what number we were putting it over? How did I know I was putting this over a 10? How did I know I was putting this over 100? How did I know that? Leor, how do I know that?
Because if it's like 0.3, then the 0 is like the 10.
Yes, exactly. So she said here, if it's 0.3, that's in the 10th place. The 3's in the 10th place. Here, we go to the farthest right number, always. That's in the 100th place, right? Here again, that's in the 100th place. So I know it goes over 100. We always look at place values for decimals in order to make it into a fraction, and then we just simplify. Let's look at this one. Now we're going to do this. Write each fraction or mixed number as a decimal. Write each fraction or a mixed number as a decimal. Who remembers how we go from fractions to decimals? How do we go from fractions to decimals? What do I do? Emma, what do we do?
You put the top number inside the box and the bottom number outside the box and divide.
Perfect. We long divide. So for all of these, to go from fraction to decimal, you long divide. That's what you do. So I want you guys to take a little bit of time and do that one. Before we continue, it makes sense. We're going to put the 19 in our box, the 25 outside, the 311 in the box, the 500 outside, the 5 in the box, and the 8 on the outside. What about this? What number is going to go in the box for this one, Lennox? What number?
3.
Yes, and what is outside the box?
5.
But wait, what about that 14? Where does that go?
Stays there.
Yeah, we don't care about it. It just stays there. We already know that it's going to be 14 point something. You don't need to worry about that 14. If it's a big number, I like to call them the big numbers. They're the integers. That's what it's called officially. But our big numbers we don't need to worry about. They just stay the same there. So let's look at this first one. Edson, what did you do? So first we put we put the first number inside the top and then the second one outside. So what did you get as your answer?
I got.
What did you get as your answer, Edson?
I got
5.75.
It is almost that. So we're going to see this. First, we know 25 does not go into 19. So we have to make a decimal. And notice that we have to add that extra 0. Decimal goes straight up. Just carries it right up. How many times does 25 go into 190? Well, I know it goes into 104 times, so it would go into 208 times, which means that it has to go in 7 times, being 175. I subtract and I get 15. So I'm going to bring down my 0. So Edson, how many times does 25 go into 150? How many quarters are in $1.50?
6 times.
6. And it is exactly 150. When you get down to a 0, you are done. Or when you get to a repeating number, we are done. We will talk about repeating and terminating decimals later again. So exactly, Edson, we get our answer to be 0 and 76 hundredths. Exactly. Tamar, what did you get for your answer for this one?
10.
10? Not 10, but we're getting closer there. Lior, what did you get?
I got 0.622.
Perfect. She got the right answer. 500 goes into 310 0 times. So I decimal, 0. You see what I do? 0, decimal, 0. Really easy. 500. This is pretty easy. I think of it in terms of 5 and I think of it in terms of 30. 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500. Up, I went too far. So it has to be 6. So that was 3,000. I subtract and I get 110. So I bring my 0 down here. How many times on our fingers does 500 go into 1,100? Yeah, those of you who are showing it goes in 2 times, which is 1,000. I now have 100 left over. I have to keep going until I either get a matching pair or I get a 0. How many times does it go into 1,000 on your fingers? It goes in again 2 times. It's exactly 1,000. I subtract and get 0. So perfect, you guys. The answer for that one, thank you, Lior, we got 0 and 622 thousandths. 0 and 622 thousandths. Jack, what did you get for this problem?
I got 625 thousandths, or 0.625.
Yes. So 8 goes into 5 0 times. I do 0, dot, dot, 0. It's just the first thing that we always do. 0, dot, dot, 0. It goes into 50 6 times. Jamal, what is 8 times 6? Lennox, what is 8 times 6?
So 8 times 6 equals 48.
Perfect. We subtract, we get 2. We bring down another 0. We know 8 goes into 2, or 8 goes into 20 2 times, and that's 16. We subtract and we get a 4. I'm going to make this smaller because I want to make sure we can all see it. We get a 4. Again, I bring down another 0. 8 goes into 40. Show me on your fingers. How many times? Show me on your fingers. 8 goes into 40. How many times? It goes in 5 times. And it is exactly 40. Look at that. We got down to our 0. So we find our answer, as Jack said, to be 0.625 or 625 thousandths. Jamal, what about this one? What did you get as your answer for this one, Jamal?
For my answer, or how I did it,
What was your answer first?
my answer, I got 2.2.
You got 2.2?
4.
Oh, the 14.2?
Yeah.
Samantha, what is your answer?
My answer was 14.6.
So exactly. So we had that 14, and we're gonna do the 0.6. We'll see if that works. 5 goes into 0, or 5 goes into 3 0 times. 0 dot dot 0. 5 goes into 30 6 times, and it's 30. There's my 0. So I just bring it right back, and I get 14 and 6 tenths. 14 and 6 tenths. Excellent work, you guys. Here's another one. So we have here fractions, and we need to turn them into percents. So according to this little pie graph that I made, I want to know, first, what percent of the days were sunny? I want to know what percent of the days were rainy. I want to know what percent of the days were sunny or rainy. That means they are combined. I want to know both of them combined. And I want to know what percent were cloudy or partly cloudy. Those are the 4 pieces of information I want you to know. This comes from this pie graph. Sunny was 11 out of 25 days. Or it was 11 25ths. Rainy was 4 25ths. Cloudy is 1/10. And partly cloudy is 3/10. Perfect. So let's see. Lennox, what did you get for what percent of the days were sunny?
I got 44%.
44% is correct. Samantha, what did you get for the percent of days that were rainy?
I got 16%.
She is correct. Let's see, Nathan, what did you get for the number of days that were sunny or rainy? Yes, it is 60%. And then lastly, Lior, what did you get for the percent that was cloudy or partly cloudy?
I got 4%.
You got 4% or what? Did you say 4?
Yeah.
Like that?
And
Not 1%. We're getting further from the answer. Emma?
40.
40%. Exactly. 40%. We're going to look at these ratio tables and we'll see. First, I had 11 25ths for sunny. I had 4 25ths for rainy. I had 1/10 for cloudy. And I had 3/10 for partly cloudy. When I want it to be a percent, what number do I always have to get it over? What number do I always have to get it over, Emma?
10.
When I want a percent, it always has to be over what number? Not 10. When I want a percent, remember our percent sign. Look at the number that's hidden in our percent sign. Nathan?
Is it 100?
It's 100. 100. Just like in our percent sign, 100. That's a cute little way to remember it. Always over 100. So to get our percents, we always need to make them over 100. We just ratio table these, you guys. To get from 25 to 100, we did times 4. So we got 44. To get from 25 to 100, we did times 4. So we do the same to the top. Like I said, what we do to the bottom, we do to the top. 4 times 4 is 16. Then 1 to get here, it's times 10. Here, again, it's times 10. So we do the same here. 10, 30. So that's what we find out. The question asked, though, for 2 of them, it asked us to combine. This one's the combination of these 2%. Do you notice? Because the 2 over there are sunny and rainy. And this one's the combination. And then this one is the combination of cloudy or partly cloudy. Because we got 10 and 30 make 40. So all it takes to do is you can just ratio table this. Now I want you to do this. Write each percent as a fraction in simplest form. Hey, we just said what every percent has below it. We just said what every percent has below it. So let's see what you guys can do. Harry, for number 1, first, what is our initial fraction? What is our initial fraction?
Can you excuse?
While we're waiting for Harry, Jack, what is the initial fraction for b?
47 over 100.
Perfect. We already know anything is over 100. Initial means first, just like our initials. Okay, Jack, can you simplify that for me?
No, 47's prime.
Exactly. That is it. 47 is prime and it does not go into 100. That is it. Let's see. Emma, what is our initial fraction?
88 over 100.
Perfect. It takes no thought. We just do that. And can you simplify that for me?
11 over 50.
Yes. Wait, not 11 over. Jaden, what is it?
44 over 50.
So it's not 44 over 50 yet. Let's see. We divided it by 2. We got 44 over 50, but we can still go further. We can still go further. Do you know
40 over 25.
what is it? What is it, Emma? Perfect. We get 22 over 25. So again, make sure that you don't just stop. You have to make sure that everything is simplified, okay? If the numbers are both even, you know it's not simplified. Harry, are you back?
Yes.
Perfect. What is the initial fraction for A?
14 hundredths.
Perfect. 14 hundredths. So then what would it be in simplest form?
7 50ths.
7 50ths. They are both divisible by 2. And then 7 is prime. And 50 is not divisible by 7. Excellent, you guys. That's all it takes. You put your fraction, or you put your percent over 100 and simplify. Are you ready for this one? I want you to write each percent as a fraction or mixed number and as a decimal in simplest form. I suggest you start with the decimals. It will help you go to fraction. I suggest you start with the decimals. It'll help you go to fractions. First, I want the form of a decimal, because aren't decimals to percents and percents to decimals? Those ones are the pretty easy ones, right? Yeah. Alina, what is 350% as a decimal? Excellent. 3.50 or 3.5 or 3 5/10. Excellent. Number B, technically. Jack, what is that as a decimal?
It is 0.0005.
Excellent work, Jack. I know you're already looking at this probably and going, Ms. Diaz, it is a decimal already. There's a decimal point right there. Yes.
Yeah,
we
you
can
just
have
to add.
Yeah, we can have decimals and fractions already. We still just need to do our bunny hops. Exactly. Edson, what is C?
0.5.
Not 0.5.
0.
We're almost there. We're getting close. Let's see, Lior.
0.0055.
Yes, 0.0055. We just need our 2 bunny hops. And then that last one, Emma, what is it?
4.80.
Yeah, 4.80, 4 and 8/10, 4.8, all of them work. Yes, exactly. Now, I want to write them as a fraction or a mixed number now. I want to write them as a fraction or a mixed number now. How can I write 3.5 as a fraction or mixed number? So this is 3 5/10. Emma, how do I write that as a mixed number?
Well, you can do 3 and 5 over 10.
Perfect. But then what?
Then you have to put in simplest form, which is 3 and 1/2.
Yes, because they have the denominator. They're both divisible by 5. So for this one, we got 0.0005 as our decimal. What is our initial fraction? What is our initial fraction? Lior, what's the initial fraction?
5 over 100.
5 over 100? No, not over 100. Lennox?
5 over 1,000.
Not over 1,000. What is it, Samantha?
5 over 10,000.
5 over 10,000. Remember place values. tenths, hundredths, thousandths, 10,000ths. And then I need to just simplify. Hey, it ends in a 0. It's divisible by 5. Jaden, what is this in simplified form for me?
Over 2,000.
Perfect, Jack. 1 over 2,000. Again, to solve this, we just divide. We just do the division. So we find out that this fraction is 1 over 2,000. Let's look at this next one. We got 0.0055. What is that as an initial fraction, Nathan? Yes, Nathan, 55 over 10,000. So now we need to simplify. Perfect. So their greatest common factor is still 5. And we get 11 over 2,000. And 11's prime. We can't simplify it anymore. So I get 11 over 2,000. 480. What is that going to be? First, what is my initial fraction? I've got 4.8. 4 and 8 tenths. What's my initial fraction, Lennox?
Your initial fraction would be 4.8.
4 and 8 over 10.
Perfect. 4 and 8 tenths, because that is our tenths place value. But I can simplify that. They're both even. What can I simplify that to, Lior?
You can simplify by 2.
Perfect. Divide by 2, and what do we get?
You get 4 and 4 over 5.
4 and 4 fits. Excellent. We can't go any further than that. Great job, you guys. Here's this one. Write each mixed number or decimal as a percent. So now we're doing it the other way around. The easier ones are going to be B and C if we remember how to do it with our little bunny hops. Emma, for this first one, 4 and a fifth, I can't make it from a fraction to a percent without doing ratio tables and all that stuff. Let's make it a decimal first. What is 4 and a fifth as a decimal?
4 and a fifth as a decimal is 2,000.
Yeah, well, it's 2 tenths, so 4.2. 4 and 2 tenths. I know you're going over it. We just long divided 1 into 5, and we got 0.2, 2 tenths. Excellent. So, Lennox, when we solve these problems, what do we do? What do we do, Lennox?
When we solve these problems, we technically try and get the percentage, so over 100.
So we're trying to get the percentage over 100. That is one way you can do it. But what I'm saying is, what is the thing that we do? I'm actually going to ask Jack, what is it that we do? What is the step that we need to do? We need to do this.
I'm sorry. You multiply to get 100.
We could multiply it to get 100, but you guys are making this way too much work for yourself. Remember with decimals, what do we do, Lior?
Bunny hops.
2 bunny hops. That's all it takes, you guys. You don't need to do any multiplication. All it is 2 bunny hops. Emma, can you tell me what direction we do the 2 bunny hops from decimal to a percent?
To the left.
Left is this way.
Oh, yeah, to the right.
This way? So why do you say to the right?
Because you're adding it. You're going towards the percentage.
Excellent. She said exactly what I wanted. We're going towards the percent sign. Based on that, Anna Jolene, what would the answer to B happen to be?
As a percentage, percentage goes to the...
She got it perfect. We moved our decimal over 2 places. We got 0.15%. Excellent. Great job, Jamal. What about the last one? What percent is that going to be? Lennox, what is the percent for C? Oh my God, stop. I apologize for that interruption. Lennox, what is it going to be for C?
I think it's going to be 264%.
Yes, 264%. Again, all we did was go 1, 2, towards the percent sign. 1, 2, towards the percent sign. That's how we remember to turn decimals into percentages. I want you guys to fill in this chart. I gave you a percent here. I'm going to put the percent sign so that we can see them here. And I want you to figure out what the decimal version of it is and what the fraction version of it is. Here I want you to find out the percent, and I want you to find out the fraction. Percent, decimal. Sound good? I want you to practice that. Anna Jolene, what is this 0.3 as a decimal? What is 0.3 as a decimal?
0.03.
0.003. We need the double bunny hop. 2 bunny hops away. How do we remember, Anna Jolene, that we do 2 bunny hops? How do we remember we do 2 bunny hops, Anna Jolene?
Wait, what? Write it on a chart.
Emma, why do we remember that we go 2?
Because there's in the percent sign.
Yeah, there's 1, 2 in the percent sign. So we make it that. And then lastly, Anna Jolene, what is that as a fraction?
Over 1,000 or
Excellent. And 3's prime, so we can't do anything like that. It's already simplified. Who would like to answer the second one for me? Jack, go ahead. What is this as a percent?
It is, okay, tell me if I get this wrong. 824.5%.
He is completely correct. We bunny hop, boop, boop, towards the percent sign. And what is it as a decimal?
It's 8 and 245 thousandths.
So we get 8 and 245 thousandths. Can I simplify that?
Yes, you can.
And what does it simplify to?
It simplifies to 49 over 200.
Perfect. I didn't know what their greatest common factor was. But I look at them and I go, hey, one ends in a 5 and one's in a 0. Let's just keep dividing by 5 until we get to the end. And look, we just divided by 5 once, and that's what happened to be their greatest common factor. Samantha, what about this last one? What is it as a decimal?
it is 0.625.
Excellent. We did that before. And if we had put that, it would be 625 thousandths. It simplifies. And then what is it as a percent then?
62.5%.
Excellent. Can percents have decimals in them, you guys? Nodding our head or shaking our head. Can percents have decimals in them? Yeah. Percents can have decimals in them. Percents can have decimals. We see that in right here. All of them had decimals in them. Here was this. I want you guys to figure this out. You're going to fill in each of these circles with either a greater than, less than, or equal to sign. Greater than, less than, or equal to sign. Jack, what is the answer to the first one? Which one's bigger?
It is number 1, the first one, so it would be greater than.
That one? Do we agree with him? What do we think? Let's turn them into fractions or decimals and see what happens. What is this as a fraction, you guys? What happens to be that one as a fraction? Emma, what is that as a fraction?
Oh, we can't see your screen.
So what is this one as a fraction then, Emma?
I did the opposite way. I did 1/4 as a decimal.
Okay, well, what is 1/4 as a decimal?
25 hundredths.
25 hundredths, yes. And that we find out then that this one's bigger. It's always easier to turn them into a decimal. Jaden, what was this one though as a fraction? I just want to hear it from you. What is it?
Was it 4/10?
Excellent. It's always easier to turn it into a decimal, but we know 4/10 is bigger than that 1/4. But it's easier to turn them into decimals. Who has the answer for B? Who would like to share the answer for B? What did you get as the answer for B, Lennox?
I got 7/8 is greater than 5/6.
Like this? Yes.
Yeah.
What is 7/8? Did you get what that is as a decimal?
No, I got it as a fraction.
So you made them have equivalent denominators?
Yeah.
That's exactly another perfect way we can do that. Hey guys, just as a side note, you can also butterfly math this. You can also butterfly math it. You can either butterfly math, you can get them to have the same denominator, or you can turn them into a decimal. What about this next one? What about this next one? Who can tell me? What is the answer to the next one? Nathan, what's the answer to the next one? Herbert, what's the answer to the next one?
Equals.
They are equal, exactly. This is 2 3/10 is how we would say it. This is 2 3/10. They are equal. What about this last one? What about this last one? What is that going to be? Which one's greater? Which one's less than, or are they equal?
7/9.
7/9 is greater. One thing that you could do is if they have the same top, 7.7 is 7/10, the other one is 7/9. Do you remember the rule if they have the same denominator? Or if they have the same numerator? If they have the same numerator, how can we tell which one's bigger, Samantha?
If the denominator is smaller,
Yep,
then it's the bigger one.
exactly. If they've got the same numerator and a smaller denominator, that means that that one's the bigger one. Exactly. So, find the percent of each number. So pretend it says, what is 6% of 95? What is 15% of 110? What is 102% of 750? And what is 3/100ths of a percent of 1500 of 1500? So let's think about that, okay, you guys? I want to ask you guys, do you remember the formula that I gave you for how to solve percent problems? What did I say? I said something over something equals something over something. Emma, what is it?
X over 6.
Our thing is over of equals percent over 100. Is over of equals percent over 100. So based on that, fill that out for all 4 of these. So for example, for this one, do we have an is? Yes or no? Do we have an is? No. So it is an X. Do we have an of? Yeah, our of is 95. We have our percent over 100. Jaden, are you able to simplify 6/100ths as a fraction for me? Can you simplify that? What are they both divisible by?
They're both divisible by 2.
Perfect. They're divisible by 2. So what do we get?
We get 3 over 50.
Excellent. And now it makes our math easier. Now it makes our math easier there. Because we can't ratio table this one. It doesn't want to work for us. So we can't ratio table this. What do I set up? What is it going to look like? On one side, I'm going to have 95 times 3. What's on my other side? Anna Jolene, what's on my other side?
Wait, on what?
Exactly. 50x. That's exactly how we write 50 times x. And what is my last step to solve this? Well, first I have to multiply that out. Did anybody multiply that out? Lennox, what'd you get when you multiplied it?
What I did is I put, times 3.
95 times 3 gave us 285. And then Lennox, what was your step that you did right there?
First I did 50x over 50, so we have to isolate the x.
Yeah, look at that word. But what else did you do? Because what you do to one side?
The other.
So we also divide that by 50. We divide it by 50, but we have to simplify. When we simplify it, does anybody know what we get when we simplify it? Yeah. She did long division and she got 5 7/10. She's completely correct, you guys. That's it. What about this one? 15% of 110. Do we have an is? No, so it's an X. Do we have an of? Yeah, so it's 110. Do we have our percent? Yes, it's 15. And do we have our bottom? It's always 100. Let's simplify. 15 over 100. What can I simplify 15 over 100 to? What does 15 over 100 simplify to, you guys? Jaden?
5. So you do 5 divided by 3.
Perfect. So you say we divide them both by 5, and on the top we get 3, and on the bottom we get?
50. No, sorry, 20.
20. Excellent. We still can't ratio table this because 20 doesn't go into 110, so we have to multiply these. I would get 20x equals 330, right? And then just like Lennox said, we need to isolate that variable. This is being multiplied. The opposite is divide. So if you long divide 330 by 20, let's see what we get. Next, what'd you get?
I got 165.
Ooh, he got 165, but he's a little bit off because he's missing a decimal somewhere. Remember, 330 divided by 20, not by 2. So where would our decimal go? Jaden, do you happen to know the answer for this one? He got 165. I'm going to tell you, a decimal goes somewhere there. Where do you think the decimal's going to go? Think about this intuitively. Jaden?
1.65.
Do we think that's 15% of 110? Does that make sense? No. What do we think, Lennox?
Would it be 16.5?
Yes, 16.5. So we can use our estimation skills. It wouldn't be 165 because we're looking for 15%, and that's way too close to 330. It's not going to be 1 point something because that's way too far. So we use our estimation skills to figure that out. Here's this one, 102% of 750. I have a question. Is our number going to be bigger than 750 or smaller than 750? What do we think? Bigger or smaller than 750? So here I get x over 750, because we don't have the is, equals 102 over 100. I know some of you don't like to simplify, but Angeline, this would be a good time to simplify, and I'll show you why. What can I simplify this fraction to? They're both even, right? So let's divide them. What can I simplify that fraction to, Angeline?
You can simplify it to...
And what is it?
5 by 2.
Mm-hmm.
And that would be 50. So you do 102 divided by 2 will be 51 over 50.
Excellent. 51 over 50. This is why I wanted to simplify it beforehand. Can I jump from 50 to 750? Yeah, that's why I want to simplify sometimes beforehand. Lennox, how many times do I have to multiply 50 to get to 750?
15 times.
15 times. So we do the exact same to the top. How do I know which direction to point my arrows? Do we remember? How do I remember, Emma?
Because we're pirates and we go to the X.
We are math pirates and we go to the X. Exactly. So we get as our answer, X is 765. Does that make sense as a number that we get for 102%? Yeah, because it's over 750, but not by too much, because it's only 102%. Exactly. What about this last one of the percent problems? We'll set it up. We don't have an is. We have an of. We have our percent over 100. Can I go from 100 to 1,500? Can I go from 100 to 1,500? Can I jump there? Yeah. What do I multiply 100 by to get there, Emma?
5.
Not by 5, we're almost there. That's 500. What is it, Lennox? 15, exactly. So I do the exact same to the top. I do the exact same to the top.
.45 over.
Just 0.45. Exactly. So our x. So 45 hundredths is 300ths of a percent of 1,500. Let's look at this one. I want our is over of here. We got our word problem. A store is having a sale where winter clothes are 60% off the original price. A sweater is on sale for $30. What was the original price? So we've got $30. Is that the part or is that the whole? Is that the part or is that the whole? What do we think?
Part.
It is the part. Yeah, I see 2 people were saying it. Lennox doing it, Angeline. So the 30 goes on top. We don't know the whole. So the X goes at the bottom. But we know it's 60% over 100. We point our arrows because we're math pirates. Hey, Jaden, how do I go from 60 to 30? What do I do?
You times by 2.
Yeah, so I'm going to divide by 2 to get from 60 to 30. I'm going to do that same thing. Harut, what is 100 divided by 2?
50.
Excellent. So it originally cost $50. Ramona calculates that she spends 15% of her school day in math class. If she spends 75 minutes in math, how many minutes does Ramona spend in school? So we already know it's going to be percent over 100. But I need to figure out, I've got this number here, 75. Is that going to go at the top or the bottom? Is that the numerator or the denominator? Lennox.
It's going to be at the top.
Emma, why is it going to be at the top?
Because that's our part.
It's our part. We don't know the whole time that she spends in school. Here's an advice for those of you who want to ratio table it. Simplify that one. We already simplified 15 over 100 before. Jaden nicely told us that we get 3 over 20. Can I go from 3 to 75 easily, you guys? Yeah, think in terms of money. Think in terms of money. Angeline, what do I multiply 3 by to get to 75?
Multiply it by 25.
Excellent. Our quarter, 25. So I have to do 20 times 25. What's our answer?
400.
500. Yes. Anime movies make up 85% of Jorge's movie collection. If he has 20 movies, how many anime movies are in his collection? So we already know percent over 100. But we've got this number 20. Where does the 20 go? Is that our numerator or is it our denominator? Is it our part or is it our whole? Is it our part or is it our whole? Anna Jolene?
It's our whole.
Yeah. So we got to figure out this. Excellent. Hey, look, I can ratio table this. I point my arrows to the X. How do I go from 100 to 20? Harut, how do I go from 100 to 20? What do I divide by?
5.
Divide by 5. So we're going to divide that by 5. Excellent. What's our answer?
1720.
17. Excellent. 17 out of 20 of his movies are anime movies. Here's this. If Devin has 3 cups of pineapple juice, how many cups of punch can she make? So I need it. It's all going to be 1 cup. This 1 cup is made up of this. This is 1 cup. And I have 3 cups of pineapple juice. If pineapple juice makes up 20% of it, how much can I make? So that 3, we're going to set it up that exact same way. We got our percent, 20% over 100%. Is the 3 the total or is the 3 the part? Is the 3 the total or is the 3 the part? Think about this carefully. Remember, it's the pineapple juice exclusively. Anna Jolene, what is it?
The part.
It's the part, because it's... We don't know what's there. I want to simplify this fraction first, because it's going to make it easier for me. What is the simplified fraction of 20 over 100, Jaden?
10 over 50.
We do. We can get 10 over 50. Can I simplify that even more? Can I simplify that even more? Emma, what can it simplify to?
5 over 25.
It can simplify, again, to 5 over 25. Can I simplify it even more, you guys? What can I simplify it to, Harut? 1/5, exactly. 1/5. And we're math pirates, so we point our arrows. What is x equal to, you guys? What is x equal to then? Tatiana, what is x equal to? Yes, it is. 15, as I see all of our hand wigglers. Yes, so she can make 15 cups of punch. This is our last question. How many cups of sorbet are used in 8 cups of punch? So we already have our 100. What is the percent for the sorbet? What's the percent for the sorbet? Can you tell me what the percent is, Emma?
15%.
15. And then that 8, is that the part or is that the whole? 8, is that the part or is it the whole? Lennox?
It's a part.
He says it's the part. Angeline, what do you say?
I think it's the whole.
Do you think it's the whole? Well, let's have a tiebreaker. Emma, what do you think?
I think it's the whole as well.
It's the whole. Because we want to find out specifically the sorbet. We want to find out specifically the sorbet. We want to figure out that.
Sorry.
Perfect. As Jaden said, we get it. We simplify. They're both divided by 5. We get 3 over 20. We still can't ratio table this, but it makes our lives a lot easier. What is our equation that we get then when we set it up to isolate our variables? What is the equation that we get then? Who can tell me the equation that I get? So when we do this, we are now multiplying like this. Lennox, what's our equation?
It equals x. It's 20x. 20.
Perfect. 20x equals what?
20x equals 24.
Perfect. And then, Anna Jolene, what are we going to do?
We're gonna.
Harut, why are we dividing? What is it called when we're doing that? What are we looking for?
4.
Yeah, well, we're going to isolate our variable. We want to isolate our variable, right? So I'm going to get x equals. Those 20s cancel out. Exactly. We wanted x by itself, so they cancel out. 24 20ths. 24 20ths. What does that simplify to as a mixed number? 24 20ths as a mixed number. Root, you have it? What is it?
4.
Emma?
4 and 1/20th.
So we're going to have 1 and 4 20ths. You reverse that a little bit, but we can simplify 4 20ths. Anna Jolene, what does 4 20ths simplify to? Is it? What did you get?
I got 1.2.
She got 1 and 2/10, which is correct because 4 20ths, if we simplified it, they're both divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. 1 and 1/5 is the exact same as 1.2. Just make sure you answer the questions the way that the test asks you to, okay? Excellent, you guys. You did so well today.